Did you know the world can farm more than 120 million tons of seafood every year? A figure humanity once thought impossible? To achieve such a massive output, the aquaculture industry has shifted into an entirely new technological era. Farms now operate with laboratory-level precision. Living environments are programmed down to the second, and entire systems function like machines that learn. And this leap forward has finally broken our dependence on the open ocean, paving the way for a production model that is proactive, clean, powerful, and far beyond the natural limits we once believed unbreakable. Unlike outdoor farming systems that require constant water exchange, a recirculating aquaculture system only needs a very small amount of new water added each day, less than 10 liters per cubic meter, while a traditional pond may need up to 1,000 liters for the same volume. The remaining water is retained and treated within the closed-loop system through 3 continuous processes. The first stage filters out solid waste, such as fish feces and uneaten feed. Next, the biofilter converts toxic ammonia into safe nitrate. Finally, the water passes through an ozone or UV sterilization chamber to eliminate pathogens before returning to the culture tanks. Within just a few minutes, the water is cleaned, stabilized, and reused up to 99%, keeping temperature consistent and conditions nearly sterile. This ability to renew the environment almost instantly turns RAS into a programmable, fully controlled production system, eliminating the traditional limitations of space and natural water conditions. Across Asia, behind the nearly 5 million tons of white-leg shrimp exported each year, lies a decades-old paradox. The pond bottom, where shrimp spend most of their lives feeding and breathing, is actually the most oxygen-deprived layer of the entire system. As traditional paddle wheels only stir the surface without addressing this fundamental bottleneck, the shrimp industry has been forced to confront the root of the problem. Oxygen must be delivered exactly where the shrimp live, not left floating in the upper water column. This is why pure oxygen technology emerged as a true turning point. Instead of relying on slow natural diffusion, the system extracts pure oxygen from the air, compresses it into high-pressure microbubbles, and drives it straight into the pond bottom, a zone that almost no previous technology could reach. As a result, shrimp don't just breathe better, they escape the toxic bottom environment entirely. Their metabolism improves, immunity strengthens, and survival rates can increase by around 20%, a number powerful enough to redefine the profitability of an entire farm. Unlike traditional square cages, circular cages use an arched load distribution structure. In this closed-loop design, forces from waves, wind, or currents are evenly spread across the entire frame, instead of concentrating at a few stress points as in square cages. As a result, the cage does not twist, shift off-center, or develop fatigue points that lead to long-term structural failure. When a large wave hits one side, the force is carried around the circular frame, allowing the cage to move smoothly with the wave, rather than resisting it. This absorb-disperse balance mechanism enables the structure to maintain its shape, even in seas with 3 to 4 meter waves. Waters with strong currents and high dissolved oxygen, ideal for species like salmon, yellowtail, and tuna to grow naturally, build muscle mass, and improve flesh quality. Most veteran marine engineers consider offshore circular cages the true starting point of industrial open ocean aquaculture. Since their introduction, marine farming has finally been able to move beyond shallow coastal zones and into deeper, cleaner, and far more stable waters, suitable for large-scale production. Not every sustainable aquaculture model requires closed-loop systems or massive steel structures in the open ocean. In Coffin Bay, South Australia, where the tide rises and falls twice a day, and the water is rich in plankton, farmers choose to work with the environment rather than replace it. Each year, rows of oyster baskets are positioned exactly within the most active flow layers, allowing oysters to grow according to their natural physiology. These baskets are made from ultra-durable polymers and designed as rotating cylinders suspended on an adjustable lawnline system. As currents pass through, each basket rotates gently, smoothing the shell surface, removing fouling organisms, and channeling oxygen down to the bottom, helping oysters build thicker shells, deeper meat, and a perfectly shaped cup. Each basket is less than 30 centimeters wide, yet its rigid frame can hold around 200 juvenile oysters. Thanks to the optimal water conditions and a farming method built entirely around natural current dynamics, Coffin Bay oysters not only reach market size, but also develop thick shells, deep cups, and uniform shape, qualities rarely achieved in conventional oyster farming. This distinction is what allows Coffin Bay oysters to be welcomed in demanding markets such as Japan and Singapore, where consumers are willing to pay significantly higher prices compared to standard farmed oysters. Compared to offshore cage farming, where fish and shellfish grow in HDPE structures engineered to withstand 3 to 4 meter waves, high oxygen levels, and constant currents, the intertidal rack and stick method represents a minimalist but intelligent approach. Instead of relying on steel frames, dozens of hectares of tidal flats use more than 50,000 stakes, working entirely with natural water cycles. Cage farming delivers high output and industrial-scale production, while intertidal farms produce oysters with thicker shells, firmer meat, and a distinct flavor shaped by the natural dry-wet rhythm that no artificial system can fully replicate. To catch hake, modern trawlers rely on a fishing system that is almost fully mechanized. The entire net, stretching 300–500 meters, is packed into a massive hydraulic net drum weighing tens of tons. When sonar pinpoints a moving school, the captain triggers the release. 2 trawl doors swing open, holding the mouth of the net steady at the exact depth where hake are swimming. Throughout the tow, sensors mounted on the doors constantly transmit data on tension and depth, allowing precise adjustments within seconds. Once the code end reaches capacity, typically 20 to 40 tons of hake in a single haul, the drum reverses, retrieving the net along a programmed path that minimizes twisting and stress. As the code end breaks the surface, a single latch is released, and the entire mass of hake spills onto the deck, completing a harvesting cycle driven almost entirely by heavy machinery and automation. But their ambitions didn't stop at the 10-kilometer mark. China's leading engineers pushed even further, developing an industrial-scale fish farming system capable of operating stably in open waters as far as 60 kilometers offshore. With a diameter of 180 meters and a semi-submersible steel frame weighing more than 7,000 tons, the entire structure is assembled on land before being towed to its ideal offshore location. A zone with strong currents, clean water, and minimal human influence. These conditions allow the fish to develop firmer muscles, lower fat content, and overall better health compared to those raised in nearshore farms. Seaweed farming may still be unfamiliar to much of Europe, but a movement to build offshore seaweed farms is emerging as a natural extension of the blue economy. In Norway, commercial-scale farms now operate on 15 to 20 hectares, with long-line systems stretching for tens of kilometers, producing hundreds of tons of seaweed each season. These ocean fields rely entirely on natural currents, tides, and nutrients drifting from nearby fish farms, allowing seaweed to grow without fertilizers or chemicals, a truly ocean-based form of agriculture. Seeded in autumn, the seaweed matures quickly, and after just 6 to 8 months, farmers can harvest it using mechanized equipment, where lifting, hauling, and collecting have become almost fully automated. Although European offshore farms have yet to reach the multi-thousand-ton scale of Asia, they are demonstrating a different kind of value: carbon absorption. According to recent trials, each hectare of seaweed can capture 10 to 30 tons of CO2 per year, depending on species and current strength, a number significant enough to position seaweed as a key piece in Europe's long-term decarbonization strategy. With a storage capacity of up to 3,200 cubic meters of seawater, a wellboat does more than transport salmon. It solves the biggest weakness of freezer vessels, which cannot preserve the fish's biological condition during transit. At the heart of this technology lies an unexpectedly small component: the fish transfer pipe that moves salmon from the onboard live tanks back to offshore sea cages. Instead of using hydraulic suction, the traditional method that often causes impact injuries and micro damage, the wellboat creates a stable biological flow, precisely adjusted to match the water velocity, temperature, and oxygen levels inside the sea cages. As a result, the salmon swim voluntarily with the current, significantly reducing stress, scale loss, and pressure shock, the very factors that can sharply reduce their commercial value once they reach the market. At depths beyond 1,000 meters, where pressure reaches 100 times that at the surface and complete darkness consumes everything, humans can still observe, analyze, and operate with millimeter precision thanks to heavy-class ROVs. The 5-ton vehicle is secured inside a launch cage, lowered by a dedicated crane, and linked to a steel-armored umbilical cable. The lifeline delivering power, video, sonar, and sensor data to the control room in real time. Throughout the descent, a dynamic positioning system holds the vessel perfectly still, providing a stable platform as the ROV moves into icy silent waters under immense hydrostatic pressure. Equipped with high-resolution cameras and multi-beam sonar, operators can visualize the seabed, read structural details, and feel mechanical feedback from the robotic arm as if standing on the ocean floor. With a single command through the umbilical, the arm goes to work, removing marine growth, freeing jammed connectors, or collecting geological samples, all performed steadily under pressures exceeding 100 bar. Located off the northern coast of Singapore, EcoArc is built like a flat-bottom industrial barge with a low center of gravity, stable enough to carry a full RAS system operating directly at sea, without needing to be anchored to the seabed. On the roof, more than 1,000 square meters of solar panels supply power for the entire facility, allowing EcoArc to operate independently even during cloudy or low sunlight conditions. Beneath the deck lies the central treatment hall, where seawater is filtered through an automated rotating drum system and continuously backwashed at high pressure to remove fine sand, suspended solids, and pathogens right at the intake. Thanks to a fully programmed and tightly controlled environment, fish grow faster, stay healthier, and achieve more consistent, higher quality flesh than in traditional open sea farming. Each year, EcoArc can produce up to 5,000 tons of fish, roughly 20 times the output of nearshore kelongs, primarily sea bass, grouper, and snapper, all high-value species. For Singapore, floating farms like EcoArc are more than technological showcases, they are essential lifelines. They allow this small island nation to steadily build a food system capable of feeding over 5.5 million people, despite limited land and increasing global volatility. With a muscular body, a swimming speed of 70 kilometers per hour, and a weight of up to 400 kilograms, the bluefin tuna ranks among the most formidable predators in the ocean. Fishermen rely on two of the most common natural hunting methods: harpooning and handline fishing. each demanding strength, precision, and masterful experience. In harpooning, the fisherman stands at the bow, watching for tuna surfacing near the water. At the right moment, he launches a specialized harpoon with an explosive tip that pierces the thick flesh and locks firmly into the fish's body. The catch is then hauled aboard with ropes or a hydraulic winch. Every throw must be decisive, a split second off, and the fish vanishes into the deep. This traditional selective technique minimizes bycatch and requires sharp eyes, quick reflexes, and immense arm strength. For many seasoned fishermen, it's more than a job, it's an art form, a battle of wits between man and one of the ocean's greatest hunters. Meanwhile, handline fishing is the more common approach. Fishermen use high-tensile carbon rods, PE lines, rated at 200 pounds, and reels with 80 kilograms of drag, tools built specifically to withstand the power of this mighty fish. When a fish bites, the angler bends the rod with full force, maintaining about 70 kilograms of line tension, strong enough to control but not to break. The rhythm of pull, release, hold repeats endlessly until the fish is worn down. Finally, even an exhausted tuna weighing hundreds of kilos still takes 2 or 3 people working together to haul it aboard. Once on deck, it is immediately chilled with ice or super-cooled seawater to preserve its omega-3s, proteins, and natural myoglobin, the key to the fresh flavor and perfect crimson hue of sashimi. Today, bluefin tuna prices have risen by 25% in just 2 years, and each premium catch can fetch up to USD $30,000. A worthy reward for human strength and determination against the power of the sea. When the herring season begins around March to April each year, fleets of vessels from Alaska's major ports head out to the rich fishing grounds, where hundreds of tons of herring gather into massive shimmering schools. Herring are known for swimming in dense, synchronized formations, the perfect condition for fishermen to deploy purse seine nets, stretching for kilometers, woven from high-tensile nylon and buoyed by floats, capable of enclosing an entire school within minutes. As the net closes, the fish move instinctively, pressing together toward the center in one unified motion. At the signal, the hydraulic winch system roars to life, hauling the massive ton-heavy net up onto the deck. The herring are funneled together, sliding up the hull under water pressure and the pull of the drum, a living river of silver. Moments later, powerful suction pumps are activated, drawing thousands of fish continuously into refrigerated storage tanks. There, the processing begins immediately. Fishermen collect female herring roe, then send it straight down deep freezing conveyors below 0 degrees, preserving the fragile nutrients that would otherwise degrade at normal temperatures. On a good day, each vessel can haul in around 200 tons of herring in just a few hours, worth up to $1 million per trip. At the height of the season, that figure can double, helping Alaska's fleets generate hundreds of millions of dollars annually. A colossal pillar of the U.S. fishing industry and the global seafood supply chain. Across the Caribbean Sea, the world's largest lobster harvesting region, more than 1 million lobster traps are deployed each year. At depths reaching 40 meters, the traps are arranged in a precise network. Each trap holds a plastic bait cage filled with chopped fish or squid. The slow diffusion of scent lures lobsters inside, trapping them in narrow chambers with one-way entrances. Everything is secured with salt-resistant polypropylene ropes, connected to GPS-marked buoys, so that vessels can return to the exact location after 24 to 36 hours. When it's time to haul them up, Crews work swiftly, sorting the catch, releasing undersized lobsters and females carrying eggs, strictly adhering to sustainable fishing regulations. The lobsters that meet the standards are immediately chilled in circulating seawater tanks, keeping a 98% survival rate. The key secret behind Caribbean spiny lobsters. Premium status, fetching 3 times the price of those caught and frozen by conventional methods. While lobster traps yield large harvests, they cause significant damage to coral reefs, where metal frames and anchor lines can break coral branches, stir up sediment, and destroy the nurseries of young lobsters. That's why in the Florida Keys, fishermen turn to a different method: manual diving, an ocean-friendly approach that relies entirely on human skill and endurance instead of machinery. Divers descend to depths of 15 to 25 meters, searching for Florida spiny lobsters hiding deep within coral crevices. Armed with a tickle stick, a slender metal rod with a gently curved tip, they carefully nudge the lobster from behind, coaxing it out of its den without breaking its antennae or scratching its shell. Each movement demands perfect reflexes and thousands of hours of training. One mistake in the crushing pressure of the deep can mean disaster. Though laborious and less productive, hand diving yields the finest catch, lobsters uninjured, unstressed, their flesh firm, sweet, and brimming with the taste of the sea, as if freshly born from the ocean itself. Millions of polyethylene mesh cages stretch beneath the ocean surface at depths of 30 meters, nurturing hundreds of thousands of Tahitian black pearls, the most precious of all marine gems. Each oyster, with a hand-implanted nucleus of mother-of-pearl, hangs in anti-fouling baskets tethered to floating lines, absorbing mineral-rich currents that build a thick, lustrous nacre layer over nearly 2 years. At harvest time, divers descend along the rows of cages, unfastening anchors and hauling the heavy oyster clusters, each weighing dozens of kilograms, to the boats by hand. The oysters are then cleaned meticulously, scraping away algae and barnacles to prevent impurities from marring the pearl's quality. Each shell is secured with a stainless steel clamp, its mouth opened just 1 or 2 centimeters, enough for a skilled technician to reach in with precision tools, separate the tissue, and extract the pearl nestled deep within without cracking the nacre. Of the thousands harvested, only around 3% achieve perfect roundness and luster worthy of fine jewelry. The rest find new life in art, decor, cosmetics, and pharmaceuticals, every pearl a fragment of the ocean's quiet perfection. From December to June, hundreds of pyramid-shaped iron traps are set along muddy waterways, turning thousands of hectares of Louisiana rice fields into the largest crawfish harvesting grounds in the world. The golden key to maintaining productivity and speed lies in specialized motorized boats, equipped with 20-horsepower gasoline engines and hydraulic paddle wheels that glide steadily across the flooded fields. Their powerful thrust lets fishermen move smoothly through the thick mud, working efficiently between trap rows and streamlining every step of the crawfish harvest. Workers lift each heavy trap, pour the wriggling crawfish onto steel sorting tables, reload bait made from grain and protein powder, and drop the trap back into the water. This process can repeat up to 1,200 times in a single morning, demanding remarkable endurance to sustain the relentless pace for hours on end. Once sorted, the crawfish are packed into mesh sacks, stacked into truck beds, and shipped out. The entire system runs like an open-air production line, perfectly synchronized between manual labor and mechanization. Each year, about 70,000 tons of crawfish are harvested, generating over $300 million for the state of Louisiana, the swampy heartland that has become a true symbol of America's seafood industry. In central China, conservation teams are racing against time to save the giant salamander, the largest amphibian on Earth, a relic species that has survived since the Jurassic era. In the cool, damp mountain streams at night, researchers carefully use soft mesh nets to capture the animals without harming their mucus-covered skin. A delicate external lung that absorbs oxygen directly from the water, yet is so fragile that even a light touch can be fatal. Once brought to the surface, each salamander is measured, tagged with an ID chip, and released exactly where it was found, the only way to monitor its genetics and population density without disturbing the ecosystem. As a top predator in mountain streams, the giant salamander plays a crucial role in maintaining ecological balance by controlling populations of small fish and insects. If it disappears, microbial levels in the water could rise by up to 40%, turning once clear streams into murky, lifeless channels within just a few rainy seasons. Salamander meat is considered a rare delicacy in some regions of China, known for its tender texture, mild sweetness, and fish-like richness, packed with collagen, protein, and natural amino acids. However, as the species faces critical endangerment, consumption has been completely banned. Instead, efforts now focus on studying its nutritional and medicinal value under controlled conservation breeding. In Japan, unagi eels are mainly raised in cement or composite tanks with recirculating water systems, where temperature, oxygen, and pH are carefully controlled to mimic natural river conditions. When the eels reach 250 to 300 grams, around 8 months old, farmers begin the harvesting process. The procedure starts by lowering the water level in the tanks, leaving only a shallow layer about 10 to 15 centimeters deep. As the eels gather near the bottom, a low-pressure suction hose is activated. Water from the tank is drawn into the hose, creating a gentle vortex that carries the eels upward without causing injury. At the outlet, a centrifugal separator filters the water back into the tank, while the eels are guided through a closed transfer pipe directly into an intermediate holding tank with circulating cold water. Here, the eels are kept alive and naturally cleansed, allowing them to purge mud and waste before being sent to the processing area. The entire operation runs in a continuous, near-closed cycle, reflecting the precision and automation that define Japan's advanced eel farming technology. Among hundreds of fish species in the ocean, only the pufferfish makes fishermen both crave and fear. Tuna demands speed. Mackerel can be caught by simply surrounding them with nets. But catching pufferfish is like playing with knives on the ship's deck amid storms and biting cold. The hunt begins with the most important element, bait. But not just any bait will do. Fishermen must use mackerel they catch themselves, carefully cleaned, cut into neat small squares, and salted to preserve freshness. Because if the mackerel's oil spoils, the pufferfish will turn away. One day's preparation can include up to 20,000 bait pieces, packed into 250 cold boxes, just to feed a single fishing line stretching 48 kilometers, with over 20,000 surgical sharp steel hooks. Once the bait is ready, the lines are cast into the sea. Tens of thousands of hooks sinking like an invisible net beneath the waves. But the risks start here. A strong wind can shift the lines, or a lost marker buoy can mean losing hundreds of hooks, worth thousands of dollars, swept away by the sea. Many fishermen have gone bankrupt because of a sudden storm. So why do they still risk fishing pufferfish? Simply because, if lucky, a single season can change their lives. Pufferfish meat is one of the most luxurious dishes, hunted in high-end restaurants in Japan and Korea. Its flesh is sweet, tender, and snowy white, but one wrong cut can expose deadly toxic organs. Fishing for pufferfish is not just a job, it's a gamble with the ocean, where the line between failure and fortune is just one pull away. As soon as the pufferfish is hauled aboard, everything switches to emergency mode. The fish is processed and frozen immediately on the boat at -40 degrees Celsius, because even a delay of a few hours can cause the meat to discolor, lose freshness, and plummet in value. Each fish is carefully packed into 10-kilogram boxes, layered in the freezer compartment like artificial ice amidst the ocean. For the fishermen, the freezer hold is a floating safe. The vault, safeguarding the hard-earned rewards of days spent gambling their lives with the deep sea. Alongside wild harvesting, Japan has developed a closed-system pufferfish farming industry to ensure a sustainable supply. This is an exceptionally sensitive sector. Only licensed farms are permitted to raise pufferfish because these fish are not just food, but creatures carrying dangerous toxins. The process begins with one of the most critical steps: artificial fertilization. During breeding season, farmers gently stroke the fish's belly to collect eggs and sperm, a task that seems simple but is actually an art, as even a slight mistake can shock and kill the fish instantly. Fertilized eggs are transferred into separate incubation tanks, where water temperature and cleanliness are tightly controlled every hour. In colder water, eggs take up to a week to develop. In warmer water, only 3 to 4 days. But the risk of fry mortality rises exponentially. The entire process is kept as closely guarded as a national secret, because in the world of pufferfish, whoever holds the breeding formula holds the key to a billion-dollar industry. Raising pufferfish isn't just fish farming, it's a high-stakes mental game with one of the ocean's most sensitive creatures. Feeding them isn't as simple as tossing food into the water. It's a precise ritual demanding absolute accuracy. Unlike tilapia or sea bass, species that'll eat just about anything tossed into their tanks, pufferfish are incredibly picky eaters. Their diet resembles a gourmet meal: fresh mackerel cut into small pieces, lightly prepared live shrimp, and sometimes high-protein formulated feed, all measured to the exact gram. At certain stages, pufferfish even consume small goldfish, live shrimp, or marine worms, delicacies specially chosen to stimulate their natural hunting instincts. Young pufferfish are raised indoors in closed environments. As they grow, they're transferred to outdoor tanks or sea cages where they swim freely, but under strict supervision. The difference lies in how close they are to nature, but wherever they are, farmers must engage in a chess match of wits with one of the ocean's deadliest fish. One of the strangest and most shocking steps in pufferfish farming is tooth trimming. This fish is dangerous not only because of its toxin, but also because of its razor-sharp teeth, sharp enough to bite through nets, destroy plastic tanks, or even attack each other. If left unchecked, a pufferfish group can turn a farming area into a battlefield overnight. Therefore, when the fish are still small, farmers perform a procedure that sounds like science fiction: catching the fish and using specialized pliers to carefully trim their front teeth. This is a painstaking task requiring millimeter precision. Pufferfish are extremely sensitive to stress. One shaky hand or slip-up can shock the fish, causing it to inflate and die on the spot. This isn't just tooth trimming, it's cutting away a piece of the fish's wild nature, transforming a creature known as a biological bomb into a luxury delicacy. After about 18 to 24 months of nurturing, the pufferfish reaches market size, typically measuring 30 to 40 centimeters in length and weighing between 1 to 1.5 kilograms. At this stage, its smooth, shiny skin, creamy white belly, and distinctive bulging eyes signal that it's ready for harvest. To catch the fish, ordinary nets are not used. Instead, specialized soft nets with round mouths and rubber edges are employed to prevent damaging the fish's skin. Each fish is carefully scooped up with utmost care taken to avoid causing stress or allowing the fish to inflate during harvest, because a single strong impact can trigger its defense mechanism, causing it to puff up and making handling much more difficult. After being carefully scooped up, the pufferfish are brought ashore for sorting, according to very strict standards. Fish measuring around 40 centimeters in length, weighing between 1 to 1.5 kilograms, and in perfect health, are carefully selected. These premium specimens are often put up for public auction at very high prices. Exceptional quality pufferfish can sell for thousands of dollars per fish, especially larger, healthier individuals with clear provenance. Typically, high-end restaurants or reputable distributors purchase these fish directly to ensure fresh, safe ingredients for serving exquisite and costly sashimi or fugu dishes. In Japan, pufferfish preparation is a highly regulated field, and only those holding a fugu license, a nationally certified qualification specifically for handling pufferfish, are permitted to perform it. To obtain this license, chefs must undergo years of training and pass an extremely rigorous examination that includes practical tests on filleting techniques, identifying toxic organs, and ensuring safe handling. Before entering the delicate preparation stage, where a single wrong cut could be fatal, many Japanese chefs follow a ritual that may sound unusual, feeding the pufferfish carrots and chili peppers. Carrots serve not just as food, but as a key cleanser for the fish's digestive system, helping to flush out impurities from the intestines and minimize risks during dissection. Chili peppers act as a natural anesthetic, calming the fish and preventing it from puffing up, a reflex that could turn the entire process into a disaster. And now, let's explore the pufferfish preparation process, a deadly delicacy sought after worldwide, where approximately 70% of its body contains toxins carefully controlled to turn a lethal threat into a perfectly safe gourmet dish. The process begins with a gentle incision on the fish's head, a crucial step that helps to paralyze the fish, reduce stress, and prevent it from inflating suddenly during handling. The craftsman continues by carefully removing all the sharp fins. However, instead of being discarded, these fins are often preserved to be used as decorative elements or incorporated into traditional Japanese dishes like tsukudani, a savory, flavorful dish served with rice, making full use of every part of this unique fish. Immediately after, the mouth is carefully removed because the fish's salivary glands also contain toxins. This step also reduces the risk of injury during processing and prevents the fish from biting, ensuring the safety of the handler. Next, the craftsman skillfully removes the fish's skin with swift and precise movements to preserve the meat underneath. Since the skin also contains potent toxins, careful removal is essential to ensure absolute safety. A seemingly simple fish, yet hidden inside are 4 deadly toxin-containing areas: the liver, ovaries, intestines, and skin. Even a small piece of these organs contaminating the meat can turn the dish into poison. Therefore, the pufferfish preparation process is carried out almost like microsurgery, where every cut must be absolutely precise. Importantly, pufferfish internal organs are not discarded as ordinary waste. They must be collected, sealed as high-level hazardous material, and disposed of according to strict procedures. Every year, Shimonoseki processes over 3,000 tons of pufferfish, generating hundreds of millions of dollars for the luxury food industry. This is not just a dish, it represents the delicate boundary between culinary excellence and life-threatening risk. Behind each paper-thin slice of sashimi, nearly translucent, lies a complex chain of steps where mistakes are almost impossible to afford. Pufferfish meat doesn't explode on the palate like Wagyu beef or offer the rich fattiness of salmon. Instead, it carries a different kind of delicacy, chewy, crisp, and refreshingly light, leaving a cool, clean finish on the tongue, as if you're tasting a slice of the ocean freshly cut at dawn. In high-end fugu restaurants in Japan, sashimi is often arranged in the shape of a chrysanthemum, a symbol of purity and a subtle reminder of the thin line between life and death. The slices are so thin they're almost transparent, shimmering on the plate like petals kissed by morning dew. Eating a piece of pufferfish sashimi isn't just a taste experience. It's a testament to the chef's absolute precision, because one misplaced cut could turn the meal into a matter of fate. In Japan and several coastal regions of China, an ancient method of octopus fishing is still practiced, using a single fishing rod with a sharp hook. No bait, no traps, just a swift jerk of the hand when sensing the subtle pull from the depths. As soon as the octopus breaches the surface, fishermen immediately stab a metal hook into its body and haul it straight onto the deck, because even the slightest delay could see the creature slip away and vanish into the night like a ghost. It may look simple, but this technique demands lightning-fast reflexes and a firm grip, since a fully grown octopus can weigh up to 10 kilograms, slippery and fiercely struggling. What's more, the octopus has no bones. Its body is so flexible it can squeeze through a gap the size of its own eye. That makes holding onto it once it's hooked not just a challenge, but an unforgiving duel between man and one of the ocean's greatest masters of disguise. In the Mediterranean, where deep blue waves kiss ancient coastal villages, many fishermen still rely on traditional octopus fishing using set nets, a method that has lasted for centuries. Long nets are quietly laid out along rocky reefs at night, waiting for unsuspecting octopuses to wander in during their hunt. While not the most efficient, sometimes hundreds of meters of net yield only a few octopuses, tangled with seaweed, small fish, and ocean debris. This method has one major advantage. The octopuses are often still alive and healthy when the boats return to port. This ensures optimal freshness as they're sent directly to processing facilities. And so, despite the rise of modern technology, many coastal communities in the Mediterranean remain loyal to their time-worn nets, preserving both tradition and the essence of the sea. Leaving behind the blue ocean, they embark on a new journey, entering a rigorous processing chain inside modern factories, where cold steel machines transform these intelligent marine creatures into finished products ready to reach the world. Upon arriving at the factory, the first step octopuses must undergo is pre-processing, a crucial starting point in the entire modern handling chain. Each octopus is placed on a workstation where workers manually remove inedible parts, such as the ink sac, internal organs, eyes, and the hard beak located between the arms. This stage is carried out entirely by hand with meticulous care and high precision, aiming to preserve the natural shape and ensure the meat structure remains intact, a key factor in the final product's quality. After the initial pre-processing, the octopus is sent directly to the washing area for thorough external cleaning, preparing it for the next in-depth processing steps. Living close to the seafloor, octopuses often hide in rock crevices, coral, or sandy caves, so their bodies are usually covered in mud, sand, algae, and a protective slime layer. If not properly washed, these impurities can affect both the quality and flavor. That's why this rough cleaning step is mandatory before any further treatment. The octopuses are transferred to a specialized spinning washer, where cold water and centrifugal force work together to remove most of the slime and debris on the skin. This device functions like an industrial seafood washing machine, octopuses are placed into a spinning chamber, where high-pressure cold water continuously sprays while the chamber rotates, stripping away the sticky layer and contaminants. On average, each cycle can clean 150 to 200 kilograms of octopus in just a few minutes, equivalent to the output of about 15 to 20 workers operating manually. However, due to their many deep grooves and suction cups, slime often remains in areas the machine can't reach. At this stage, workers must hand scrub each octopus using a specialized soft brush, focusing especially on the spaces between tentacles, where bacteria tend to accumulate if not thoroughly cleaned. On average, one worker can clean about 80 to 100 octopuses per hour. This is not just a hygiene step, it's a meticulous, repetitive, and highly precise process. After washing, the octopuses are sorted by weight and size, usually divided into three main categories: under 500 grams, between 500 and 1,000 grams, and over 1 kilogram. After sorting, the octopuses are divided into two main processing directions. Larger ones continue to the boiling and freezing line, while the smaller ones, often referred to as baby octopuses, are taken to the tray packing area. Here, workers carefully arrange each baby octopus into stainless steel trays, with their heads and tentacles aligned in the same direction to form neat, organized rows. Once neatly arranged, the trays are sent straight into the deep freezing chamber. Inside, the temperature is rapidly reduced to below -35 degrees using advanced cooling systems, freezing the octopuses within 1 to 2 hours. This process locks in freshness, preserves the original shape, and inhibits microbial growth. After freezing, each tray is separated, and the octopuses are vacuum-packed in PE bags, passed through a metal detector for food safety, then boxed, labeled with traceability info, and stored at -20, ready for export worldwide. For larger octopuses, post-harvest handling isn't as straightforward as with baby octopuses. Instead of being frozen immediately, they must undergo an important thermal bath, parboiling at 95 to 100 degrees Celsius for several minutes. This step is key to preserving firmness, shape, and color. Skipping it could result in mushy, bland flesh with no elasticity, greatly reducing commercial value. Under near-perfect temperatures, the meat firms up, retaining its moisture and natural sweetness. Then comes the magical transformation. In just a few minutes of boiling water, the octopuses turn from pale gray to a vibrant reddish pink. This color shift isn't due to dyes or tricks, it's a natural biological reaction. You're probably familiar with boiling common seafood, but have you ever wondered why this strange phenomenon happens? Immediately after boiling, the octopuses are plunged into a deep cold water tank for a thermal shock, a crucial step that instantly halts the cooking process, preserves firmness, and prevents overcooking. Without this step, residual heat would continue to cook the meat from within, breaking down the protein structure and resulting in mushy texture and loss of elasticity. From the cold tank, the octopuses move onto a drainage conveyor, where tiny grooves and a stream of cool air help dry the surface quickly and evenly. This preparation step is essential before packaging, as excess moisture can negatively impact both flavor and shelf life. After being perfectly boiled, the bright red octopuses are quickly transferred to the preliminary packaging area, where every operation takes place in a strictly sterile environment. Here, workers carefully arrange each octopus into specialized golden trays, ensuring they lie neatly without bending or overlapping, preserving their elegant appearance like a true culinary artwork. The trays are then wheeled straight into a cold storage room, where the temperature is consistently maintained between 0 and 2 degrees Celsius. This isn't just refrigeration, it's a resting phase that allows the octopus meat to reach optimal texture and freshness, ideal for sashimi slicing or final stage packaging. In the final stage, modern industrial systems take over. Whole octopuses and separated tentacles are placed into form-fitted trays, then passed through a high-speed vacuum sealing and film wrapping line. This all happens at lightning pace, thousands of trays per hour, ensuring that every product meets strict hygiene standards, comes with traceable origins, and is ready to conquer premium supermarket shelves and the world's most demanding markets.